During the Cold War, submarines were having a secret competition. The Soviet Union built submarines out of titanium that could dive deeper than anything America had. When the US Navy found out, they realized they were losing an invisible war. So they did something radical. They started building submarines out of the same metal the Russians were using. This metal, titanium, the same stuff in your toothpaste, became a matter of national security. And the story of how we learned to use it is just as dramatic. But here's the thing, we almost never figured it out at all. In 1791, a clergyman named William Gregor was studying black sand near a stream in Cornwall, England. He noticed something strange. The sand was heavy, the sand was magnetic, and it was nothing like anything he'd ever seen. When he tested it, he discovered traces of a completely new element. Gregor called it monaconite after his village, but almost nobody cared. A few years later, a German chemist named Martin Heinrich Klaproth rediscovered the same element. He looked at this mysterious metal and realized its potential. He renamed it titanium, after the Titans of Greek mythology, the powerful giants. That name was fitting for what was coming. Here's the problem nobody expected. Titanium doesn't exist in pure form in nature. It hides inside stubborn minerals like rutile and ilmenite. They look like ordinary black sand and rock, but inside them lies one of the strongest metals on Earth. The challenge was getting it out. The moment scientists heated titanium, it reacted fiercely with oxygen. It became brittle. It crumbled. It was useless. For over 100 years, brilliant chemists tried everything. Different temperatures, different chemicals, different methods. Every single attempt failed. Titanium was locked away like a vault nobody could crack. Scientists had the key, they just didn't know what it was. The metal fought back against every extraction attempt. It wasn't until 1940 that everything changed. A metallurgist named William Justin Croll figured it out. Instead of fighting titanium's reaction with oxygen, he worked around it. He used magnesium in a sealed, controlled environment. No oxygen, no reaction, just pure titanium emerging from the process. This technique, called the Croll process, was revolutionary. For the first time, titanium could be produced at scale. The sleeping giant was finally awake. But Croll's breakthrough didn't just solve a chemistry problem. It unlocked an entirely new era of technology. Within decades, titanium went from laboratory curiosity to essential material. Airplanes needed it. Spacecraft needed it. Submarines needed it. The world needed it. The journey from sand to metal happens in stages. First, mining companies dig up massive deposits of ore in places like Australia, South Africa, and Canada. The ore contains rutile and ilmenite, minerals loaded with titanium. These get transported to processing plants. Stage 2 is chemical transformation. Scientists treat the ore with chlorine and carbon at extremely high temperatures. This creates a clear liquid called titanium tetrachloride, or TCl4. It looks innocent, but it's highly reactive and dangerous to handle. Then comes the magic. Using the Croll process, this liquid gets heated with magnesium inside a sealed chamber. Out comes something bizarre, a dark, porous material called titanium sponge. It doesn't look like metal. It looks like a sponge made of metal, but it's pure titanium, finally separated from everything else. The final step removes any remaining impurities. The sponge goes into massive vacuum furnaces. These superhot chambers drive out oxygen and nitrogen, the enemies of pure titanium. What emerges gets cast into ingots, rods, sheets, or wires. These become the building blocks for everything from aircraft fuselages to artificial hip joints. And here's something most people don't realize. The titanium dioxide created during this process doesn't get wasted. It becomes your sunscreen, your toothpaste, your paint, your makeup. The answer is simple. Titanium does things no other metal can do. First, it's incredibly strong, almost as strong as steel. But here's the kicker. It weighs 45% less. That changes everything for aircraft. Less weight means less fuel. Less fuel means cheaper flights and longer range. Engineers call this a game changer. That's underselling it. Second, titanium doesn't rust. Not in rain, not in salt water, not anywhere. This is why submarines and naval ships depend on it. The ocean is the harshest environment on Earth, and titanium laughs at it. Third, titanium is biocompatible. The human body accepts it like it's supposed to be there. Doctors use it for hip replacements, dental implants, and surgical tools because it never causes rejection or allergic reactions. Finally, titanium tolerates extreme heat. Jet engine temperatures can reach 1,000 degrees Celsius. Most metals would melt or weaken. Titanium gets stronger. At those temperatures, a protective oxide layer forms on its surface, making it even more resistant. But here's what makes titanium truly special. It combines all of these properties in one metal. Nothing else comes close. Yet this miracle material has one massive weakness. The catch is cost. Titanium is expensive. Mining costs money. The Croll process demands precision and energy. Purification requires massive furnaces consuming enormous power. Processing a single pound of titanium can cost 10 to 20 times more than a pound of steel. But during the Cold War, cost didn't matter. The Soviet Union poured resources into titanium submarines. Soviet submarines made of titanium could dive deeper and faster than American submarines made of steel. When the Pentagon found out, they didn't hesitate. They started building American submarines from titanium too. This became a hidden arms race. The space program had the same mentality. Titanium appeared in the Apollo spacecraft. The State Route 71 Blackbird spy plane was 85% titanium. Modern SpaceX rockets contain titanium in critical engine components. When lives are at stake and national security is on the line, cost becomes irrelevant. Titanium became essential to human achievement. It took us deeper into the oceans. It took us higher into space. But the military and space agencies weren't the only ones who discovered titanium's value. Right now, more than 1 million titanium implants are placed inside human bodies every year. Every year. Hip replacements, knee replacements, dental implants, spinal fusions, pacemakers, artificial joints. Each one represents a person getting a second chance. A chance to walk, a chance to smile, a chance to live without pain. Titanium does something remarkable inside the human body. Within weeks, bone actually grows around it and bonds with it. It becomes part of you. A titanium implant can last 20, 30, even 40 years. Some are built to last a lifetime. That's not just engineering. That's restoration. That's hope in metal form. Millions of people are walking right now because of titanium. But titanium's story isn't finished. It's actually just beginning. Here's a fact that should disturb you. We recycle only 5% of titanium. That means 95% of used titanium gets thrown away. A titanium bicycle, a titanium prosthetic limb, a titanium engine part, all discarded. The main reason is contamination. Once titanium is used, it picks up impurities that make recycling difficult. Scientists are working on better recycling methods. If they succeed, costs could drop by 30%. But there's another path. New extraction methods are being tested. Electrochemical processes, plasma reduction. These could cut production costs in half within 20 years. When that happens, titanium won't be exclusive to aerospace and medical applications. It could show up in cars, in buildings, in everyday tools. The question isn't if it'll happen, it's when. You've been walking on titanium your entire life. Literally, black sand beaches around the world are titanium deposits. The sunscreen protecting your skin contains titanium dioxide. Your toothpaste is white because of titanium. Your makeup, your paint, your food coloring. Titanium is everywhere and invisible. For 150 years after its discovery, titanium was a sleeping giant. We had it all around us, but couldn't use it. Then one man solved the puzzle in 1940. Today it powers jets, submarines, and keeps people alive. But researchers are already working on the next generation. Titanium foam, titanium composites, 3D printed titanium structures. The metal that took 150 years to master is about to evolve again, and we still don't fully understand what it's truly capable of becoming.